Today, we're diving into one of the coolest and most mind-blowing topics in science right now. The idea that scientists have created an artificial wormhole using a quantum computer. Yeah, you heard that right. A wormhole. Like those shortcuts through space in sci-fi movies. Back in 2022, Google and a team of researchers made headlines with this experiment. And even in late 2025, it's still pushing the boundaries of what we think is possible. If you're into space, quantum physics, or just wild future tech, stick around, because this is going to blow your mind. Let's break it down step by step in simple terms. First, let's talk about what a wormhole actually is. Imagine the universe like a big, folded piece of paper. Normally, to get from one side to the other, you'd have to travel all the way across the flat surface. That's like normal space travel, super slow and far. But if you poke a hole and connect the two folded sides, boom, instant shortcut. That's a wormhole, also called an Einstein-Rosen bridge, named after Albert Einstein and his buddy Nathan Rosen, who came up with the idea back in the 1930s. In theory, wormholes come from Einstein's general relativity, which explains gravity as curved space-time. Black holes are extreme versions of that curvature, and wormholes could connect two distant points, maybe even different parts of the universe or parallel universes. The problem? Natural wormholes, if they exist, would collapse instantly unless something exotic like negative energy holds them open. And we've never seen one in real life. Now, fast forward to quantum physics. Quantum mechanics is the weird world of tiny particles where things can be in two places at once, or instantly connected no matter how far apart. This is called entanglement, Einstein's spooky action at a distance. For decades, scientists have been trying to merge quantum mechanics with gravity because they don't play nice together. We don't have a full theory of quantum gravity yet, but there's this cool idea called the holographic principle. It says our three-dimensional universe might be like a hologram projected from a flatter, quantum version of reality. This brings us to the big experiment in 2022. A team led by Maria Spiropoulou used Google's Sycamore quantum processor. That's a quantum computer with super-cold qubits, the quantum version of bits. They didn't build a real physical wormhole you could crawl through. Sorry, no time travel yet. Instead, they simulated something equivalent using a simplified model called the SYK model, which mimics quantum gravity through the ADS/CFT correspondence. Basically, a math trick that links quantum particles to gravitational effects in a curved space. Here's how it worked in easy terms. They entangled qubits on the quantum chip to represent two sides of a tiny wormhole. Then, they sent a bit of quantum information, like a message, into one side by shocking it with energy. Thanks to entanglement, that info popped out perfectly on the other side, just like it traveled through a traversable wormhole. It was like quantum teleportation, but with gravity-like behavior baked in. The results were published in Nature, and it showed that information could cross this simulated wormhole without getting lost. Okay, I know what you're thinking. Was this a real wormhole? Not exactly. It's a holographic simulation, an analogy in a super-simplified universe with different rules from ours. Some experts, like Scott Aronson, pointed out it's more like advanced quantum teleportation than a sci-fi portal. But it's huge because it's the first time we've used a quantum computer to probe ideas from quantum gravity in the lab. It's like creating a tiny toy model to test big theories about black holes and the universe. So, why is this such a big deal? Well, understanding quantum gravity could unlock secrets about black holes, the Big Bang, or even how the universe works at its deepest level. Plus, quantum computers are getting better at simulating stuff that's impossible for regular computers. And speaking of progress, let's talk about where we are in 2025. Things are moving fast. One major trend is hybrid computing, where quantum and classical supercomputers team up. Classical computers are great at some tasks, like checking errors or handling big data, while quantum ones shine at tricky problems. This combo is making simulations more accurate and scalable, meaning we can handle bigger, more realistic models without everything falling apart from noise. In November 2025, researchers pulled off something incredible. They used Europe's new exascale supercomputer, Jupiter, to fully simulate a 50-qubit universal quantum computer. That's a massive leap. Simulating just 50 qubits classically takes insane power, like petabytes of memory, because each extra qubit doubles the complexity. This shows how powerful our regular supercomputers are getting, and it helps test quantum algorithms before running them on real hardware. Looking ahead, the big challenge is scaling up. Right now, these wormhole simulations are in low dimensions and simplified models. To get closer to real quantum gravity, like in our actual universe, we need quantum computers with way more qubits and much lower error rates. Researchers are developing new techniques for that, and hybrid systems are key. We're talking better error correction, more stable qubits, and smarter ways to combine quantum and classical power. Imagine in the next few years, bigger simulations of wormholes, maybe even testing ideas about what happens inside black holes, or if gravity is truly quantum. This could lead to breakthroughs in physics, new tech like ultra-secure communication, or even better materials and drugs designed with quantum help. Guys, we're living in an exciting time. That 2022 experiment wasn't the end. It's just the beginning. Quantum computers are evolving, and they're giving us tools to explore questions philosophers and scientists have pondered for centuries. Is the universe holographic? Can we teleport information through space-time? We're getting closer to answers. What do you think? Would you step through a real wormhole if we ever make one? Drop your thoughts in the comments, smash that like button if you're hyped about quantum tech, and subscribe for more videos on space, science, and the future. Hit the bell so you don't miss the next one. Thanks for watching. See you soon.